All right, so this is actually going to be a video for my high school geometry class. All right, so this one is going to be the review for the geometry test that we just took. All right, guys, so let's get started. This first problem says, Carl claims that for some centers of dilation of a line, the line will remain unchanged. He is tasked to prove his claim using the line y equals 5x minus 10 and a dilation with a scale factor of 2. Which center of dilation could be used to support Carl's claim? All right, so what's the key word to notice here is the word unchanged. All right, that's the most important thing, because if the line is remaining unchanged and we're dilating it, the only way a line is going to remain unchanged after a dilation is if the center of dilation is on that line. All right, so what we can do here is we can do this. So the second most important thing in this problem is going to be this equation of a line that we have, which is y equals 5x minus 10. Well, why is that equation important? Because the centers of dilation that are going to keep this line from changing its position are going to be points that satisfy this equation. All right, it's going to be they're going to be solutions that satisfy this equation. All right, so from Algebra 1, you guys remember that when you're finding solutions, all you have to do is plug in the points, and then if those points work out to yield a statement that's true, then we say that that point lies on that line, right? So for example, 0, 0, what you're going to do is you're going to plug in 0 for x and 0 for y into this equation. When you do that, you get 0 equals 5 times 0 minus 10. 0 equals 5 times 0 is 0, minus 10 is going to give you the negative 10, and that's obviously not a true statement, so we're not going to select this one. All right, and the next point we can plug in is negative 535, but if I'm on a test, you notice that you're going to have to multiply 35, which might take a while. Or you're going to have to plug in 5, and it looks like a little bit more algebra. So I would maybe check this next letter, which is C. So I'm going to plug in 1 for x and negative 5 for y. So I get negative 5 equals 5 times 1 minus 10. That's negative 5 equals 5. 5 times 1 is 5 minus 10. So I get negative 5 equals negative 5, and that is a true statement. So we select that one. Right? And it's not saying select all that applies, so we know we only have one answer, and that answer choice in this case is going to be letter C. All right, let's go to this next one. This next one is saying line M is drawn on the coordinate plane below. Points A, -1, B, 1, 1, and C, 2, 1.5 are on line M. All right, so they pretty much just gave you the coordinates of these points. The question's saying line M will undergo a dilation of scale factor 2. All right, it doesn't say about a point. Okay, so that's very important to notice here. Line M will undergo a dilation of scale factor 2. All right, so originally I assumed that it was going to be about the origin, but thank you to Ian, who pointed out that they never gave us a center of dilation for this problem. So what they were talking about when it says line M will undergo a dilation of scale factor 2, that just means that we're going to take this original line here, we're going to take this original line and just double its length. But this line's already infinite, so its length is going to remain the same. So what we can say here is we can say which of the following centers of dilation will the image of line M after the dilation be the same as line M? Okay, so pretty much all it's asking us to do is to find a center of dilation that's gonna keep this line from remaining unchanged. Okay, from being unchanged. So that's exactly what we're gonna. It's pretty much exactly what we did up here. All right, but now it's for this problem. All right, so what you need to do is you need to go find the points that are on this line that keep this line from moving. All right, so what we can do then is we can go through each one and see which ones are gonna be solutions to this line. And note that in this case, it says select all that apply, which is important, right? So what we can do is we'll go through each one and we'll see if it's on this line. So the first one is -4, -1.5. So -1, -2, -3, -4, -1, and yeah, -1.5. If you'd like, also, you can also, so we know that, so we know that this is one of our answers. Okay. Instead of, sometimes there's different ways to understand problems. So for instance, in this problem, you can count squares. All right, counting squares is okay. You know, if you see it in the problem and you can point it out real quick, and you can just say, okay, let me count squares real fast. Another way to approach this problem is to actually find the equation of this line. So what you'd want to do in this case is there's two ways, right? You're given point. You could use point slope form, or you could use the fact that you see that from the dots, you see that the slope here is up 1/2, right? So how I would find that is I would say here's this point. I would go up 1, right 2, 1, 2 to get to that next point. Okay, so that kind of helps you. So 1/2 x, and you can see that your y-intercept here is +1/2. All right, so you could use that, and then what we could do is we could plug in this next these remaining numbers into here. But I think the square method is going to be a little bit easier for this problem, just simply because you can just count them. So let's go ahead and look at the next one. The next one says -1, -3, -1, -3, -1, 2, 3. No, that point is not on that line. So for example, if we were to choose letter B as a center of dilation, this line would move, okay, for sure. All right. Letter C, 0, 0. No, that point is not on this original line. So if we chose it, it's not gonna keep the line the same as line M, all right, because it's not on the line. The only points that the only centers of dilation that keep the line from changing are centers of dilation that are on the line, right? So now we have 3, 2. So we go over 3, 1, 1, 2, 3, up 2, 1, 2, and yeah, you can see it right here. Okay, so we'll select letter D as one of our answers. And the last one is 4, 2.5, over 4, up 2.5. 1, 2, 3, 4, 1, 2, 2.5. So yeah, that one works also. All right, counting squares can be pretty quick and pretty efficient on tests if it works out. All right, you may sometimes want to double check your answer and just see if this equation holds true also. So for example, if I wanted to check and verify that 3, 2 was a solution to this equation, and in fact 3, 2 was on this line, what I would do is I would take the equation of this line and I would say let x equal 3 and y equal 2. So I would end up with 2 is equal to, okay, there you can see letter E now. You would say letter 2 is equal to 1/2 times 3 plus 1/2. So you would get 2 is equal to 3.5. 1/2 times 3 is 3.5 plus 1/2. So you'd get 2 is equal to 3/2 plus 1/2 is 4/2, which is equal to 2. Okay, so we know the equation checks out. So that point will keep this line from being unchanged. All right, hopefully that makes sense to you guys. This next one, let's go to this next problem. This next problem is going to be number 3. And it says, select each statement that is true about the image of line M after a dilation of scale factor 2 with center of dilation 2, 0. So they're still referring to this line M, so maybe we'll bring it back real quick. So the problem looks somewhat like this. All right, maybe I'll do that. Hopefully you guys can see it. That should be okay. All right, so it says select each statement that is true about the image of line M after a dilation of scale factor 2 with center of dilation 2, 0. All right, so the first thing you want to do is you want to go find 2, 0. And 2, 0 is right here. And the second you see a 2, 0 being there, right now we're given the center of dilation. And the second we see that 2, 0 is there, we know that the center of dilation is not on this line. So because the center of dilation is not on this line is definitely going to move somewhere. Okay, and it's going to move, and all of these points are going to move with a scale factor of 2. So what I mean by that is this. So remember, when you're dilating and you have a center of dilation that's not on the line, like in this case, okay, the center of dilation is 2, 0. All right, so first things first, I would put a point at 2, 0. So here's 1, 2, up 0. Here's 2, 0. What does it mean to, now we're saying dilating by a scale factor of 2. What does it mean to dilate by a scale factor of 2? To dilate by a scale factor of 2, what you need to do is take all of these points and move them with respect to 2, 0 twice as far as they are away now. All right. So for example, letter A is 1, 2, 3 units away, and because the scale factor is 2, we need to double its distance away from the center of dilation. So this point is 2, 0, and it's 1, 2, 3 away. That means it needs to be 1, 2, the new point A, I'm going to call it A prime. The new point A needs to be 1, 2, 3, 4, 5, 6 away from the center of dilation. All right, so here's our A prime. Likewise with point B, if you could see point B is left 1, up 1 away. So because the scale factor is 2, this new point B needs to be left 2, up 2 away. So left 2, up 2 away will be here. And then letter C, as you can see, is 1.5 straight up, right? 1.5 straight up, so it's 1.5 straight up. So if letter C needs to be twice as far away, it's going to be 1.5 times 2, which is 3. So 1, 2, 3. All right. So as you can see here, we kind of have this nice this other line that came about here now. It looks like this. Okay, and this line right here is actually exactly parallel to this line. Okay, which is actually going to come up here right now. So let's look at our option choices that we have. Letter A says the image of line M after the dilation is parallel to line M. Okay, that's definitely true. Because recall that when your center of dilation is not on the line that you're dilating, then that new line that the new line that you're going to be graphing is always going to be parallel to line M. Okay, so so that center of dilation, whether or not it's on the line or off the line, is very important. Okay, in this case, it was off the line. So our line that came from dilating this line has to be parallel to this line, right? So now what we can do is, let's go to the next one. It says the image of line M after the dilation is perpendicular to line M. Okay, that's definitely not true. We just graphed it. It's not perpendicular, it's parallel. So we'll cross that. We don't need to pay attention to that one. Letter C says the image of line M after the dilation passes through the point 0, 2. Well, let's see what happens here. Does it pass to the point 0, 2? Does this new green line pass to the point 0, 2? Yeah, here's over 0, up 2, 1, 2. That's B prime. So we'll select that one. The image of line M passes through the point 0, 2. The image of line M after the dilation passes through the point 2, 0. No, that's not true. Here's 2, 0 is our center of dilation. But just because the center of dilation, it was in the problem, doesn't mean that the new line goes through it. So we're not going to pay any attention to D. E says the image of line M after the dilation passes through the point 2, 2. Okay, so over, let's go 1, 2, up 2, 1, 2. Okay, and no, we see that that point 2, 2 is not on this green line. All right, so again, this is a select all that apply answer, so you do need to go through all your option choices and verify that there's none left to check. All right, so let's go to number 4 now. We're done with that graphing problem. Number 4 says, Ms. Hussein told her class that some dilations make figures bigger, some make figures smaller, and some make figures to the same size. Select 2 of the scale factors that support Ms. Hussein's claim that some dilations make figures smaller. All right, so numbers between and strictly between. All right, so what I'm going to use here is I'm going to first use inequality notation. So any number less than 1 and greater than -1, all right, so not equal to 1, okay, so we're not, and not equal to -1, because that's just multiplying it by the identity of it, so you're just multiplying by the same thing. So we don't want to include 1, okay, and obviously you don't want to include any numbers that are larger than 1, okay, so we're not giving any of those. But we also don't want to include any numbers that are smaller than 1. The reason we don't do that is because when your dilation factor, when your scale factor is smaller than -1 or equal to smaller than -1, then not only is it going to be increasing in size, but it's also going to be changing position, okay? And it's not, and so for example, if this is our line here, let's say that was our line, and we had a scale factor, and here's our center of dilation right here, okay, at the tip of this pen. And let's say that our scale factor is a positive. So that means this line is going to move in the positive direction and it'll look like that, okay? But let's say so maybe like this. Maybe our scale factor is 2, so it would exactly double in size. All right, it's kind of hard to see because of the pens. But let's say that's our scale factor 2. All right, so what a negative would do, a -2 would just do this. It would just go the opposite direction. All right, so that's why we don't select the numbers that are less than -1. So how you should a more sophisticated way to write this, and for you guys to get familiar with all your inequalities, is to use absolute value notation. So how you would say that is you would say absolute value of x less than 1. Or in some cases, you would say absolute value of k less than 1, right? Okay, absolute value of k less than 1. That means all numbers with size and magnitude less than 1. That means the numbers between 1 and -1. And I also want to throw this in there. I asked you guys in class how you get rid of this absolute value sign when you're dealing with other equations, or if it ever comes up again. And how you get rid of an absolute value is you just put plus or minus. So if I wanted to get rid of this absolute value sign, I would just say plus or minus k. Okay, and just be careful when rearranging this new inequality. All right, it does matter the order you put things in, but that's how you get rid of the absolute value. You just do plus or minus. All right, let's go to the next problem. Number 5. Oh, I'm sorry. We didn't answer these. Okay, so the numbers that we need to choose here are numbers that are pretty much the decimals that are in between 1 and -1. So that means letter D and letter E. All right. Now we can go to the next problem. Okay, so this is number 5, I believe. Yes, we're on number 5 now. And it says, line segment ST and point P are shown below. The line segment undergoes a dilation by a scale factor of 1.5 through center P to produce line segment S prime T prime. All right. So we know this line is undergoing a dilation that's larger than 1. That means it's going to increase in size. So what I would do next is I would look at these options that I have. I have the option to choose that this new line segment, S prime T prime, is going to be 5.5 in length or 6 in length. And then I'm also going to have the option to choose that S prime T prime over ST, or S prime T prime over ST is equal to 2 or equal to 1.5. All right. On the test, it was actually formatted with a ratio here. Okay, so this actually looks like a ratio. So what we're going to do is pretty much do what the directions ask us to do. So it says dilate this line by a scale factor of 1.5. Well, what's the original length of this line? The original length of this line is 1, 2, 3, 4 units. All right, so ST itself is equal to 4 units. But it says S prime T prime is going to be 4 times the scale factor of 1/2, so we multiply by 1.5. And you guys are good at algebra, so 4 times 1.5 is going to be 6. All right, So we can see which of the following equations are true, select all that apply. Well, we go ahead and select S prime T prime equals 6 as one of our answer choices. And then we go here to the ratios. And hopefully you guys can see the commonality between what's going on here. So scale factor of 1.5, it's a little obvious that we need to also select this one, right? Because if we were to set up this proportion, right, S prime T prime over ST, S prime T prime is 6, ST is 4, and when you do that, you get 1.5. All right, not much to this problem. The wording was a little bit confusing because it said through center P, but it was just important to realize that it really does not matter where the center is, because no matter where this line was lying in the XY plane, we were going to multiply it by 1.5. All right, we were going to multiply by 1.5 and get our new line. And then with that new line, we can always set up a proportion again, all right? Which is pretty much the gist of this problem. Okay, hopefully that makes sense. Let's go to number 6 now. So now we have number 6. It says, Maria claims that triangle ABE is similar, okay? That's similarity, right? So she's claiming that triangle ABE is similar to triangle ACD. So what we can do here is to select all that apply problem. So we want to be careful, and they're actually being nice in this problem. Look, they're saying select 2 of the transformations. That's pretty nice. Select 2. So we know there's only 2 answers that are right. So what we want to do here is go through each one. So first things first, Maria is claiming that these triangles are similar. Now, if her claim is correct, and we want to find things that support her claim, then what we're saying is that this triangle right here, ABE, it can be multiplied. It can be if two shapes are similar, then we can perform rigid transformations, and also we can also perform dilations to map one figure on top of the other. So we can pretty much put figures on top of the other using translations, rotations, reflections, or dilations. All right, so if two figures are similar, then we can use any 4 of those transformations to get this smaller triangle on top of this larger triangle, all right, to map onto, all right? So that's what we're gonna do here. So let's look at this first option we have. The first option we have, it says a dilation with a scale factor of 3 about point A. All right, so about point A, that means A is going to be our center of dilation. So a scale factor of 3, that if we apply that to the smaller triangle, that means every single point, which in this case is the obvious ones are B and E. B and E are going to be scale factor of 3 times away from point A. All right, so point A is our center of dilation. So everything, if letter A is an option, everything from point A needs to move 3 times away from where it already is. Okay, so let's look at letter, for example, let's see if it works out for letter B. If I scale letter B 3 with a scale factor of 3 about point A, it means I'm going to move point B 3 times away from point A as it already is. So right now you can kind of see, let's see if I can zoom in. You can kind of see that B is 1, 2 away. So the next case, if we scale it by a scale factor of 3, it's going to be 1, 2, 3, 4, 5, 6, because 2 times 3 is 6. So here is where our new point B prime would be. All right, and we can also do the same thing for point E. So right now, point E is down 2, 1, 2 over 1, 2, 3, 4. Okay, that's where point E is at. It's down 2, right 4. Well, if I scale it by 3, and we're working with 2, 4, then I need to multiply these coordinates by 3, each one. So I'm going to get 6, 12, and let's see if that point works out to get mapped onto one of these other points. So down 6 from the point A, 1, 2, 3, 4, 5, 6, right 12, and I'm not going to count because you can see this is -6 and here's 6. We know that distance is 12. So yeah, so that means point E is actually going to fall exactly onto here. It's going to fall exactly onto D. And that being said, now we know that ABE maps onto that larger triangle ACD with a scale factor of 3 about point A. So we can select it as one of our answers, right? That's one of our answers. And for the sake of time, there we go. All right, so we know letter A is one of our answers. And for the sake of time, what I'm going to do now is I'm going to, I want to say that the other answer here was C, but let's go through it, okay? So I know we had to translate downwards. So scale factor of 2 about point A. No, that's not going to work. So I'm going to go ahead and do letter D, all right, just for the sake of time. All right, so let's go ahead and do letter D and see if it checks out. Because it says select 2, so only 2 are right. So I'm going to go ahead and try letter D. It says a dilation with a scale factor of 3 about point B, followed by a translation of 4 units downward. Okay, so now note that it says about point B. Okay, so now what we're going to do is we're going to take this small triangle here, ABE, and we're going to dilate its points. We're going to multiply its points by 3, and then translate 4 units downward, and we're going to see if that new triangle that we get falls on top of this triangle ACD. Okay, so let's go ahead and do that. So scale factor of 3 about point B. So here's point B. We're going to fix it. We're going to hold it fixed while we dilate because it's our center of dilation. Point A right now is 1, 2 away. According to this thing, we're doing a scale factor of 3. So instead of point A being 1, 2 away, it needs to be 6 away. So 1, 2, 3, 4, 5, 6. So it's up here. And now what we can do is, so here's, maybe I'll call it A double prime. And so maybe I'll connect this line here. And then I'm going to do the same thing for point E. So right now, E is 4 units away from B, but our scale factor is 3. So instead of it being 4 units away, it needs to be 12 units away, which is going to be right over here. All right, so we end up with this triangle. This triangle here. Okay, and then it says, lastly, it says translation of 4 units downward. So what we do is we take every single one of these new points, in this case, we'll call it B prime, A double prime, B double prime, and E double prime, and we drag each one 4 units downwards. So you go 1, 2, 3, 4 downwards with this one, and you end up exactly on D. Go down 4 again. 1, 2, 3, 4. Point B double prime ends up on this point C. And then when you do A double prime, you get 1, 2, 3, 4, and that point falls exactly on the original A. Okay, so that also checks out. All right, and if you also wanted for extra practice to go through the rest of these to verify that they didn't work, you could. All right, but in this case, I just guessed. All right, so we know this is our answer also. Okay. So yeah, on an actual test, you do want to go through and make sure each one of the, actually on an actual test, what I would do is if I found one that worked and I found the next one that worked before, I'd be confident, and I would probably, unless I had time at the end to go back and check. All right, so I would just select them. Okay, let's go to number 7 now. So let's be on the back of this. Okay, awesome. All right, so now we have this problem. Says, what must be the length of PQ in order for triangle JKL to be similar to triangle PQR? Okay, so we have triangle JKL, which is going to be this one. And then we have triangle PQR, which is this one. All right, we want to find the length of PQ. That means this length here. A couple ways to do this problem. All right, let's say you don't want to put X here. Okay, so you do want to put X here. And that's what you want to start doing when you're trying to, when you're given problems like this and you're not told the unknown value. You want to put an X there because that's what X stands for. It stands for unknown. You normally go and find out what X is equal to in math problems. But let's say you forget to put it here. Here's what you could do. You could set up a proportion with this triangle and then set it equal to this triangle. So what I'm saying is you could do 9 over, I would do in this problem, I would, let's go ahead and do 9 over 21. Let's see what happens. Why not? All right. So I'll do 9 over 21, and then I would set it 9 over 21, and I would set it equal to 6 over 14. All right. And pretty much what I would do next is I would cross multiply and find out what the proportion is equal to. But now you see the problem of doing this and not putting an x is you're forced to find this constant. You'd have to use long division unless you could simplify it a little bit better. So let's see, 9 over 21 is really equal to what? It's equal to 3 goes into 9 3 times. 3 goes into 21 7 times. So you would have to convert this to a fraction real quick, find that decimal, and then go multiply 12 times this. Okay, which you could do, but I'm not going to do that. What I'm going to do is, since we want to find the length of PQ, I'm going to put an x here. Okay, I'm going to make my proportion easier. So I'm going to do 9 over x equals 9 over x equals 6 over 12. Okay, you do the corresponding sides. 6 over 12. Then you multiply. Okay, so for those of you who, maybe you guys forgot what I'm doing here. So when you have something like this, 9 over x equal to 6 over 12. What you want to do is you want to get rid of these fractions, right? So you multiply both sides of this one by x, both sides of the equation by x, and multiply both sides of the equation, we'll go one step at a time. So when you multiply both sides of the equation by x, these x's cancel, right? And you get 9 is equal to 6 over 12 times x. And then you want to get rid of this bottom 12, so you multiply both sides of the equation by 12 now. And then these 12s cancel, and you'll get 12 times 9, which is going to be 108. So you get 108 is equal to, these 12s canceled out, 6x. Divide both of them by 6, and you will get x to be equal to 6 goes into 10 one time, 6 goes into 6 goes into 10 once, 6 times 1 is 6, bring down to it's 4, bring down to 8, 6 goes into 48 8 times, and you get 48, 0. So you get 18. All right, that's the best way to do this problem. Okay, that's the best way to go about it, and that's the fastest way to get your answer. Okay, so when it says, whenever you're not given us, whenever you're not, in all math problems, when you're not given a side, put an x there. Okay, see what happens. See if you can find x, and if you plug it back in, see if it makes sense. All right, that's a lot of times a good way to approach problems. All right, hopefully this problem made sense. Let's go to the next one, number 8. Okay, so number 8 now. Number 8 says, based on the drawing below, in order for triangle ABC to be similar to triangle DEF by SAS similarity, so recall SAS similarity stands for side, angle, side, similarity. Okay, this is a similarity sign. All right, side, angle, side. That means two sides. That means a side is proportional, and then in that same order we have an angle is proportional, and then after that we have another side is proportional. So what we're saying is, it says based on the drawing below, in order for triangle ABC to be similar to triangle DEF, note the way my pen moves here. Triangle ABC similar to triangle DEF. All right. Which of the following needs to be true? Okay, so what we want to do here is we want to be careful on the angle that we're choosing. All right, so we're told that we want this to be true by side, angle, side. So they gave you this angle right here, this 52. They gave you that to throw you off. All right, so remember, side, angle, side has to go in that order. So we have to have a side, then we have to have the congruent angle, and we have to have the next side. So in this case, it's clockwise, right? But then what you need to recognize is that this one and this one's like a reflection of that one. So if you want side, angle, side for this one and this one, if you want side, angle, side similarity between these two triangles, we need this side to be similar to this bottom side, okay, and then we need this angle on the inside to be congruent to this angle here, okay. So what that tells us is that we need this angle here, F, needs to be 38. If we want side angle side similarity, it has to work in the motion, okay. It has to flow in that order, okay. In this case, it went the opposite way, but it was consistent, right? Side angle side, side angle side. All right. That's pretty much it for this problem. All right. All you had to know was side angle side similarity and how you have to be consistent with the way you move, and then you get 38 for this angle. Letter number 9. It says, what statements show that triangle ABE is similar to the triangle ACD? All right, so we need to go through these statements. The first thing I'm going to do here is I'm going to extend these parallel lines. Okay, these parallel lines right here, I'm going to extend them because when I notice in class, when you guys extend lines and you guys start noticing transversals, the problem becomes much easier for you. So let's go ahead and do that then. And I'm also going to extend this line also. I'm going to extend all these lines. And I recommend you do this kind of stuff on the EOC too. All right, you're going to have scrap paper, extend lines, make it look a little more something like you're familiar with. Now we have transversals, right? Here's transversal, here's transversal. And now we can check out our corresponding angles because of the parallel lines. So let's see what happens. It says, which statements show that triangle ABE is similar to triangle ACD? First one, angle ABE. So that means angle ABE, angle ABE. So remember, when that letter in the middle is the angle they're referring to. So angle ABE is this one right here. Is congruent to angle ACD. ACD would be this angle. And yes, that helps for similar. Yes, that's gonna show that triangle AB. That's gonna show that triangle ABE is gonna be similar to ACD because we already have this angle A here. This angle A is already part of both triangles. All right. So remember, angle similarity. All right, very useful. Angle similarity. Angle similarity. Okay, so the fact that angle ABE is congruent to ACD, we're gonna have angle similarity, which in turn is gonna tell us that we have similarity. Okay, it's gonna help us have similarity. All right, so we're gonna select this one. Okay, and these in fact are congruent. Okay, triangle ABE is congruent to. I'm sorry, see I said triangle. Angle ABE is congruent to angle ACD. As you can see, maybe if I did this real quick, it will help. You can see that these two are corresponding, right? We have the parallel lines, and then we have this transversal coming through, and then we have the corresponding angles here. All right. Angle A plus angle C is 90 degrees. Angle A plus angle C is 90 degrees. No, if you think back to all the notes we've taken and the principles that we've looked at, says nothing that the sum of angles being equal to 90 degrees, the sum of two angles being equal to 90 degrees doesn't tell you anything about similarity. All right, let's look at angle C plus angle D. Angle C plus angle D. Okay, so that means this angle plus this angle. Angle C plus angle D. Okay, that means these two are equal to angle B plus angle E. That's going to help for similarity for sure, right? Because that's going to give us angle again, right? Here's angle, here's angle. Now that's very helpful because now we know all three of these angles. Right? Angle C and angle B helps. Okay. I'm gonna stop there and we'll pick this up in the next video. Thanks for watching, guys. All right, guys. So we left off on this problem. It says it was saying that which statements show that triangle ABE is similar to triangle ACD. So I went through these first two, A and C, and this next one, letter D, it says triangle angle 30. It says angle A is and angle C are 38. Okay, just because angle A and angle C are 38, that doesn't tell you anything. That doesn't tell you anything about another triangle. Okay, we want to talk about similarity. So we need to involve both triangles. If we're going to talk about two triangles being similar, it only makes sense to involve both triangles if we're talking about two triangles being similar. All right, so now we have angle ADC, and and angle AEB. AEB. So now we're talking, because now we have two. Now we're talking about two angles. And we're talking about two triangles being similar. Angle ADC, that's this angle here, and AEB, that's this angle here. They're saying that they're both equal to the same number. Yeah, that's going to help us. That concept, the fact that that's true, is going to help us show that we have similarity. All right, so that's going to be for this problem. Okay. Here we have this problem. Okay, it says Keith is attempting to solve the Pythagorean theorem by using similar triangles. After Keith has set up the appropriate ratios and solved, he ended up with two equations. He ended up with a squared equals CD and b squared equals CE. It says, what must Keith do in order to complete the theorem? Okay, so intuitively, hopefully you remember this from algebra, pre-algebra. A squared plus b squared equals c squared. Okay, so if you were to even take a guess in this problem, I would say add the two equations. All right, but what's more important to notice for this problem, which we didn't have too much time to discuss in class, is that there's a lot of proofs that involve proving the Pythagorean theorem. Okay, in this case they say solving the Pythagorean theorem, but you know, proving and solving, proving is what they mean to say. And there's lots of ways to prove the Pythagorean theorem. I suggest you guys just get familiar with different ways to prove it, and as you do that, you'll realize that when you're proving the Pythagorean theorem, you always end up adding something and then subtracting something else. But in this case, if we're going to add these two equations, you see how nice it works out. We get a squared plus b squared equals cd plus ce, and then we can factor out, we get a squared plus b squared equals, we can factor out a c here, right, from pre-algebra. We can factor out a c, and we get d plus e, like that. But as you can see here, d plus e is how long? Length c. So we end up with a squared plus b squared equals c times c, which is c squared, and then we get a squared plus b squared equals c squared. All right, that was too fast. Just go ahead and pause and rewind it. But that's pretty much it, guys. I suggest you guys do look at some Pythagorean theorem proofs, and we're going to look at some of them later. Pythagorean theorem. All right, and there's a lot of ways to prove the Pythagorean theorem. You can use a trapezoid, which is what I'm doing with my pre-algebra class. You can use a trapezoid. You can use squares. And then what you do when you have squares is you add and subtract stuff to prove it. Okay, there's a few of them. One that I recommend to go look at, which I thought was pretty nice, is actually by the James Garfield, who was actually the 20th president of the United States. Isn't that interesting? The 20th president of the United States, 20th president, he actually he proved the Pythagorean theorem using a trapezoid. All right, I find that pretty remarkable. All right, let's go to the letter 11. So I do suggest you look at some of this stuff. All right, but yeah, all we did was add them. Okay, you saw that over here. And now let's go to number 11. Number 11 says, a student examines the triangle shown above. He notices the lines BE and CD look parallel. Okay, so this guy's saying, this guy or girl is saying, this line is BE, this line is CD. This person is claiming that they're parallel by look alone. That's never a good idea in geometry, right? To just claim something true by look. So we want to verify. How are you going to verify if these two lines are parallel? Well, remember one of our principles said that these two lines for a triangle are parallel if the proportions of the sides of these sides involving the lines are equal. So that's what we do. We set up a proportion involving the sides. So 6 over 3 equals 12 over 9. And immediately you can see 6 divided by 3 is 2. It's not equal to 12 over 9. Okay? So we say no because 6 over 3 this should say not equal to. And on the test, it had some weird formatting, but it should have said not equal to. All right, I think it had some weird formatting on the test, but hopefully you saw that the answer was no, and no was the only option you were given. Okay, no is the answer here. All right, the other three are yes. The answer is no, because the proportions are not consistent. They're not equal to each other. Okay, so these lines are not parallel. All right, so now we can go to the next problem, which is going to be number 12. Yeah, we're getting close. Catherine wants to prove that the measures of the interior angles of a triangle have a sum of 180 degrees. She draws a triangle and extends one of the sides through a vertex. She then draws a line through this vertex that is parallel to the opposite side as shown in the diagram below. It says, which of the following statements must be true and could be used as part of Catherine's proof? So like all that apply. Measurement of angle 1 equals measurement of angle 5. Measurement of angle 1 equals measurement of angle 5. Ooh, that's pretty nice. All right, we want to show that the sum of the interiors is 180. It's going to be pretty nice to know that 1 and 5 are corresponding, right? Can you guys kind of see that? If I extend this line like this, and like this, so what? Sorry, this was way too crooked. Should have went like that. All right, but yeah, you can see angle 1 and angle 5 are corresponding, so we know they're equal to each other. That's going to help us because if, for example, guys, what we want to show is that the interior angles of a triangle have a sum of 180, right? So we're going to need this, right? And then we're going to use some other stuff also, okay? But what we want to show is, another one we want to show, which maybe I'll skip to real quick, is this one that we need to show. 3, 4, and 5 add to be 180, right? Okay, we have a straight angle here. Straight angles are 180 degrees. Okay, angle 2 is equal to angle 4. Measurement of angle 2 is equal to measurement of angle 4. Well, here's measurement of angle 2. Here's measurement of angle 4. And as you can see, those are alternate interior, right? Alternate interior, and we know those are also equal to each other. Okay, so that's why we select this one, we select this one, and we select this one. All right, angle 3. Let's look at why we don't select letter C. It says measurement of angle 3 is equal to the measurement of angle 4 plus measurement of angle 5. No, that's not even true necessarily, right? So notice that the ones we chose here are the ones that are necessarily true, given what we have. We chose 1 and 5 to be equal because 1 and 5 are corresponding with these parallel lines, okay? We chose 3, 4, and 5 to sum to be 180 because that's what it is. We had a straight angle. 3 being equal to 4 plus 5, angle 4 plus 5. No, we don't even know if that's true or not, right? We don't know if the only case that would hold true is if the numbers actually worked out, and we can't assume that, right? So we don't select it. E says 1, 2, 4, and 5. 1, 2, 4, and 5 are 180. No. 1, 2, 4, and 5 add to be 180. No, that's not true. Okay, so they're trying to say that this one plus this one, these two, adding up to be these two. No, we've never seen that principle before. So we're not going to do any silly stuff and select things that we've never seen. Okay, just be consistent and use the principles and knowledge that you have from class. This next one says Carl is attempting to find the value of x by using side splitter. Okay, remember side splitters, pretty neat name. Carl set up the proportion 6 over 3 equals 12 over x. Okay, so he did 6 over 3 equals 12 over x. And I'm saying if Carl is correct, what should his answer be? If Carl is incorrect, what is the correct proportion? Okay, so he wants to find the value of x by using side splitter. Yeah, that's a good idea to use side splitter. All right, remember side splitter is pretty helpful. Okay, side splitter says that these two lines are parallel. And when these two lines are parallel, that means this line is proportionate to this line, and this line right here is proportionate to this line. So yeah, he's using a side splitter. He's on the right track. So what we can now do is we can solve this equation, and instead of doing it how I did in the first part of the videos, I'm going to just do this. And when I do that, I'm going to get, meaning multiplication, I'm going to get 6x equal to 36. Divide both sides by 6. I'll get x equals 6. And yes, x equals 6. Carl is correct. All right. Pretty simple problem. Recognize side splitter is very useful. Okay, when you have side splitter, you've got some stuff going on that's going to work out nicely for you. All right. Next problem is going to be Yes, number 14. Okay, we're getting there. 14, 15, 16. Okay, awesome. Yeah, we're getting there. All right, let's see this one. It says, examine the figure below. We have these two triangles. They're telling us they're similar. We have similarity already. Determine the measure of angle A. So we have similarity. But if we have similarity with these two triangles, with just this information, then we have to have similarity by side, angle, side. We have to, because they're saying these triangles are similar. But if these triangles are similar, and this is all the information we're given, and all we're given is that a side, an angle, and a side is the side is proportionate. Okay, that implies that the sides that implies that the sides have to be proportionate, and these angles need to be congruent and equal algebraically. Okay, so what we're going to do is we're going to find. It says determine the measure of angle A. How are we going to determine the measure of angle A? Well, we need another equation. And look here, we have that equation. So what we want to do is we want to find x, okay? So let's use what we know. What do we know? We know these angles are the same. We know they're equal. So let's set them equal to each other. We get 3x plus 18 equals 4x plus 2. We'll subtract 2 from both sides because you guys are in love with positive numbers, okay? And then we'll get 3x plus 16 equals 4x, and then we'll subtract 3x from both sides, and we'll get 16 equals 4x minus 3x is 1x, and you get x equals 16. But look here, trying to trick you, you saw 16 because you solved for x, so now you're in a hurry to finish the test and you select that, but no, okay? Determine the measure of angle A. We want this measurement of this angle, okay? So what we need to do is we need to plug in 16 into this, so we'll do 3 times, we're going to plug in 16 for x, so 3 times 16 plus 18. 16 times 3 is going to be 48, so we get 48 plus 18, which is equal to 66. All right, and that's why we choose this answer. All right, hopefully this problem made sense, guys. So we're told that they're similar, but the only way that these triangles are similar is by side, angle, side, because of the information that we're given. We wanted to recognize that. We wanted the measure of angle A, so we set these equal to each other, and we found x real quick. Then we had to plug x back in. Okay, you got to plug x back in. Okay, you don't want to don't jump too quickly to conclusions. All right, let's go to this next one now. It says, which of these statements regarding any two triangles, ABC and XYZ, can be proven to be true? So what I'm actually going to do with this one is I'm going to do this with this one. I'm going to write this out because that's the most practical way to approach this problem. So let's see what's going on here. It's saying I'm going to do let's just look at letter B, okay, for the sake of time. Let's see why letter B is the answer. So first things first, two triangles ABC and XYZ. So what do I know? I know that we have to notation for triangles has to be consistent. So if this is ABC, if this is triangle ABC, then triangle XYZ has to look like this. Okay, now what are they saying? They're saying if AB, oh, now we're giving congruency. That's really nice. If AB is congruent to XY, AB congruent to XY, BC is congruent to YZ, BC is congruent to YZ, and AB is congruent to and angle B is congruent to angle Y, angle B is congruent to angle Y, then the two triangles must be congruent. Is that a true statement? Yes, because if you notice what just happened when we did this, we end up with not only we don't end up with side angle side similarity, we end up with something even better than side angle side similarity. We end up with side angle side congruence. That's really nice. Okay, so yes, these have to be congruent because now we have side angle side congruence. Side angle side, side angle side. These triangles have to be congruent, must be congruent. And that's your answer. All right, it's not a select all that apply, and you can go through the rest of these on your own if you wish. Number 16. 16 says, in the figure below, triangle ABC is similar to triangle DEF. Find the length of EF. Okay, so they want you to find this length. They want you to find this length here. Okay, so, and we're told that we have similarity. Okay, and that's what we're gonna use that fact, and we're gonna use it by setting up proportions. Okay, so I'm gonna do this one over this one, which is gonna be 4 over x plus 2 is equal to, it's gonna be 7, right? Because we chose this side over this hypotenuse. Now we need to choose this side over this hypotenuse. 7 over 2x plus 1. And when you cross multiply with these, hopefully you guys are getting a little bit better with your algebra, okay? So when you do that, you need to be careful to put parentheses around these bottom guys, because otherwise you're gonna end up with just wrong answers, okay? So this comes out to 4 times 2x plus 1 equals 7 times x plus 2. What can we do now? Distribute everything, right? We're gonna get 8x plus 4 equals 7x plus 14. Subtract 7x from both sides and simultaneously subtract 4 from both sides. We'll end up with x equal to 10. Oh, looky there, there's 10. No, wrong. Find the length of EF. EF, we need to go back and plug in x. Okay, a lot of you guys chose this for your answer. Okay, be careful. All right, take your time. X equals 10. So you want to go ahead and plug this back in to find the length of this side here. Okay, so we need to plug in 10 for x. 2 times 10, right? Plus 1. 2 times 10 is 20. Plus 1 is 21. All right, 21. All right, player wins. That was number 16. I think we are on number 17. Yes, this is a fun problem. I like this problem a lot. Okay. It's a very simple problem also, which is nice. A lamppost is 6 feet high and casts an 8-foot shadow. 6 feet high, 8-foot shadow. Same time, a flagpole near casts a 20-foot shadow. Using the properties of similar triangles, find the height of the flagpole. Well, so what do you have to do here? Well, guys, you know this entire test is about similarity and congruence and proportions. That's what you guys set up here. Some of you guys in class were saying that you set up a proportion, but you got the wrong answer. It's because you set the proportion up incorrectly. It's because you did 6 over 20 equal to 8 over h, or you did something else that's a little silly, okay? You need to be consistent. So if you're going to do 6 over 8, you need to do that it's equal to h over 20, right? If you're going to set up a proportion that looks like this, 6 over h, you need to make it equal to 8 over 20. All right, these two are the same. These two are the same. These two are the same proportion. All right, so whichever one you choose to do works, but you need to be consistent in which one and how you set it up. Okay, so try to remember that. I'll do this real quick. I'll just do this one. So what do I get? I get 120 equals 8h. Divide both sides by 8. 8 cancel. I get h is equal to, I always forget what happens. 8 times 1, you get 8. 4 comes down 0. Okay, 15. And I didn't have to do that. I highlighted it. Anyways, now you guys always work on your don't forget long division. You need to know it. So now you get c equals 15 feet. All right, and we are good. That's going to conclude this test. Hopefully that makes sense. All right. I know you geometry guys were begging me for a video. So here's your nice test review for similarity and congruence and all sorts of that stuff. All right, thanks for watching, guys. Hope you enjoyed it. I'll see you guys in some the next videos.